We're going to use what we call truth tables today. And so how a truth table works is you give a statement, okay, and then you have what we call a hypothesis and a conclusion that go with the statement, okay? And that can be true, it can be false. It depends on what the statement is and what the hypothesis and conclusion are. So a conditional statement. So the first thing you want to know is a conditional statement. So a conditional statement is basically just a statement about in which you give a hypothesis and a conclusion. Okay? So that's the first thing that you need to know. That's your base statement. So you can write it in words in two different ways. And it goes like this. If P, then Q. Okay? If it's Saturday, then it's the weekend. Okay? If P, then Q. P is your hypothesis. Q is your conclusion. P implies Q. Saturday implies that it's the weekend. And then in symbols, which is what you want to get used to, is this right here. P implies Q. That arrow is significant to us. So you need the right notation for it. So this reads, if P, then Q. If it's Saturday, then it's the weekend. All right? That's what we call our conditional statement. To write the converse of conditional statement, switch the hypothesis and the conclusion. All right, so the second most important word that you're going to do today is converse. And like I said, there's 4 words, and the only thing that you can do is mess up because they're very similar. There's converse, there's contrapositive, conditional, and reverse. Or inverse, sorry. So converse. If Q, then P. So if Q, then P. So if it's the weekend, then it's Saturday. Now, is that 100% true? No, it's not, right? So that's where we're going to get to. We have to be able to prove these statements. Are they true? Are they true for going one way? Are they true for going the other way? So is the conditional true? Is the converse true? If so, then we call that biconditional. All right, so there's another one we got to look at. So a conditional statement is either true or false. A truth table for a conditional statement, P then Q, can be set up as shown. A conditional statement is false only when the hypothesis is true and the conclusion is false. Otherwise, the conditional statement is always true even if the hypothesis is false. All right, so this is how this works. And again, it sounds, when I read it to you and you read it to yourself, it sounds terribly confusing. But there's only one thing in there that you have to take from it that makes it all go together. So I have a statement that says P. I have a statement, the conclusion says Q. And then P implies Q. Okay? So if P is true and Q is true, then P implies Q has to also be true. All right? So I'll give an example in a minute. So that's Saturday, that's the weekend. If it's Saturday, then it's the weekend. All of that is true. Okay? If they were both false, then the statement is also true. It's Friday, or let's say it's Thursday. It's not the weekend then. Therefore, if it's Thursday, then it's not the weekend. It's the week. Okay? It sounds goofy, but I'm trying the most easy way of putting this, okay? False, true. True. Okay? So if this is false and this is true, then it's still true. The only way the implication can be false, the only way, is if the hypothesis is true and the conclusion is false. If it's Saturday, then it's the week. That's false. Okay, now I'm going to use a better example than that in a second here, but I just need you to base this. This is the money statement that we have to remember. Again, you have a cheat sheet. Put it on your cheat sheet. Put this truth table on there. Because you're going to get examples and you're going to have to tell, is the conditional statement true? Is the converse statement true? Is the inverse statement true? We're going to go into all of those right away. Go ahead.
For the F and T, how would that be? Like if you do it, like say if it's not Saturday, then it's the weekend, is that kind of the same? Like,
I don't like using negatives just yet. If it's Thursday,
then it's the weekend, is that what that's saying?
yeah, essentially.
So would that
Okay.
be false?
Yeah, all right, so we're going to,
That's where I am right
I
now,
know.
Brendan.
I'm going to use a better example that explains this, okay? The Saturday and the weekend part works great, obviously for the first part, but that's not what it's set up for. So, it says here, I'm going to look at this and then I've got something else to do. If a conditional statement and its converse are both true, you can combine them to create a biconditional statement using the phrase if and only if. All right, so if P implies Q is true, if Q implies P is also true, so using this example, if it's Saturday, then it's the weekend. If it's the weekend, then it's Saturday. Okay, doesn't hold. There is a way that you can prove that false, right? Because it could be Sunday, but it still doesn't mean that Saturday is not the weekend, right? Okay? Then the biconditional statement. So yet another word, vocabulary word that you need to know. Biconditional, spell it out in my head, is this. P implies Q, Q implies P. The arrow works both ways. That's what we call biconditional. Now biconditional, a statement is only biconditional. Bless you. If P implies Q and Q implies P are both true. Okay? Again, I'm giving you the basis for this. Now I'm going to jump ahead, then I'm going to come back. Go ahead to page 80. I'm trying to give you all of the vocabulary words right now that you need to know. So the next one is the inverse. The inverse. As well as the converse of a conditional statement, the inverse and contrapositive of the statement can also be formed. To form the inverse of a conditional statement, negate the hypothesis and the conclusion. Not P implies not Q. Those are the negatives. Not Saturday means it's not the weekend.
That's false.
Right, like there is another example that can prove that it's false using Sunday, obviously. But I'm just trying to set it up right now so that you understand what the not means. Okay, the negation. I'll use a better example that will not break down. But for right now, understand that the squiggly line means not. It's the negative. It's the inverse. Not P implies not Q.
If it's not P, it'll always be not Q.
No, we'll discuss this in a second.
Oh my goodness gracious. This is like, it's so simple, it's hard.
Form the inverse of a conditional statement, negate the hypothesis and conclusion. To form the contrapositive of a conditional statement, exchange the negatives of the hypothesis and the conclusion. So in symbolic form, that means then, so the contrapositive is not Q implies not P. So if you look in the box, it explains it in 4 quick statements. The conditional statement, if P implies Q. The converse of that statement, if Q implies P. The inverse of that statement, not P and not Q. And the contrapositive is not Q implies not P. Those 4 statements you need to know. And you need to use them in examples. All right, so let's flip back now. Okay, a better example. Consider the following conditional statement. If it is Saturday, then I will go to the movies. If it is Saturday, then I will go to the movies. So the conditional statement. If P implies Q. Bless you. Saturday implies going to the movies. Verify when this conditional statement is true or false. Confirm your results with a Venn diagram. Okay, so it's Saturday. I don't use Venn diagrams for these for the record, but you can. It shows you how to. If it is Saturday, I'm going to go to the movies. All right? So, statement may be true depending on who you are. Okay, we're going to say that it's true. If it's Saturday, then I'm going to go to the movies. All right? So then the converse of this statement is what?
If it's not Saturday, I'm not going to the
No.
movies. Or
If I'm at the movies, it's Saturday.
Say that again.
If I'm at the movies, it's Saturday.
So the converse of it is, the converse of this statement is, if I'm at the movies, then it's Saturday.
Okay.
The inverse of this statement,
if it's not Saturday, I'm not at the movies. Is that right now?
so if it's not Saturday,
I'm not at the movies.
I'm not at the movies. Right?
Yeah.
Okay, so then what is the contrapositive?
Not the
Nope.
movies, not Saturday.
That's okay. Yeah. Mhm.
It's not Saturday.
No, I don't think so.
Yeah,
Hey, the pepperoni, it's in the gym, correct?
yeah. Multi-purpose room?
Just in the multi?
Yes.
It's in the multi. Yeah. Yeah. I guess so, yeah. Okay, no problem.
Was that cool?
Inverse. Okay, so then what would be the contrapositive of this?
If I'm not at the movies, it's not Saturday.
No movie
It's Sunday.
implies no Saturday.
No. That Saturday is
Or
not,
inverse
Saturday's casual.
If it's Sunday, then I'm not.
No, we're gonna, no.
Saturday's canceled you.
It all is based on the original statement. So we aren't adjusting anything. So if the original statement says, if it's Saturday, then I go to the movies, that's all I'm focused on. Okay, that's what I was trying to get at when you were bringing in Sundays and whatever else. It's all based on your conditional statement. So if your conditional statement only works for Saturday and movies, that's all you're working with. So now everything else goes from that point. Okay? So the truth table says this, all right? Since the hypothesis is true or false and the conclusion is true or false, there are 4 possible cases, all right? So again, let's look at our truth table. So if P is true, so let's say it is Saturday, and I do go to the movies. Is the statement Saturday implies movies, is that true?
Yes.
Yes. Okay. Let's say it's not Saturday, and I don't go to the movies. So it's not Saturday, and I don't go to the movies. Is that statement true? Yes, it is. Right, according to my original statement. If it's not Saturday, and I do go to the movies,
You're a liar. You're a liar.
false. Okay, so here's the thing. Your hypothesis is false. It's not Saturday, but I went to the movies.
That's
So it's still true.
that doesn't make any sense.
Okay?
No, the correct answer is you're a liar.
If P is false and Q is false, it's not Saturday, and I do not go to the movies. Since it's not Saturday, I do not have to go to the movies. Case 2 is true. If P is false and Q is true, it's not Saturday, and I do go to the movies. I did not say whether I would go to the movies on any other days of the week, so that it's true. So it says that I do go to the movies on Saturday, right? It doesn't say that I don't go any other day of the week.
We're gonna focus on
So the statement reads then that it's not Saturday because it's false. That statement's false, but I did go to the movies. But nowhere in there does it say I can't go any other day of the week. So that statement still remains as true. But if I go to Saturday, if it is Saturday and I don't go to the movies, then it's false. Because I've already said, if it's Saturday, I'm going to the movies.
Then you're a liar.
You understand what I'm saying here?
This is so difficult. but it's
Okay,
so simple.
we gotta stop whining about this.
Happy birthday.
Like,
Yeah.
seriously, you guys finally get something that's easier. It's not anything that's complicated, and you guys just won't open your minds to it and just take it in. Like, talk about it, figure it out.
We're trying. Make us
Okay? So, a conditional statement bases only on two things. Saturday and the movies in this case. So, I'm saying that if it's Saturday, I'm going to the movies. That statement's true. Okay? So now, I'm only focused on those two pieces of information. Doesn't matter what other day of the week, whatever. That's just the things that for my truth table, that's all I'm focused on. All right? Let's look at the inverse. Let's find out. Okay? Actually, let's go back to this first because I need to know if it's biconditional. If it's Saturday, I go to the movies. If I go to the movies, does that imply that it's Saturday?
No.
Not necessarily. But it could. Good. But it's not, right? So then we have to say that that's false. Therefore, you don't have a biconditional statement. Because this is true, this is not necessarily true. Right? Okay. Determine whether the converse, let's look at a different, no, I just asked you this one. Determine whether the converse of the conditional statement in example 1 is true or false. So we flipped it. Movies, Saturday. So I went to the movies, therefore it's Saturday. Is that true? No, it's false. Right? Because it doesn't mean that I had to go on Saturday, even though I went to the movies. Okay? So therefore, this is what we would not consider a biconditional statement. A biconditional statement means that this has to be true, and this also has to be true when you look at your examples. All right? Let's look at the examples on page 80. Consider the following conditional statement. If the month is January, then the next month is February. So if it's January, then I know then the next month is February. That's my conditional statement. Verify the statement or disprove it with a counterexample. Verify the inverse or disprove it with a counterexample. Verify the contrapositive. All right, so let's just write out the 4 statements. The inverse statement. The inverse of this statement is what?
If it's February, the next month is January.
Last month is January.
Well, I don't know what million though.
If it's not,
Well,
if it's,
It's February, the next month is in January.
Well,
yeah,
that's- you can
if
state
the
that
next
it's
month
false
is not
here.
February, it is not January.
Oh, we're gonna be living over here.
Okay, we're going to leave this guy for 1 second. Okay? just because of the wording. We're gonna leave it for 1 second. Let's just look at the, or sorry, no, that is the one I want. I wanted the inverse,
Yeah.
right? Yeah, so if it's not January, then the next month is not February. What do you say? Is that true?
Yeah.
If it's not January, then the next month can't be February. Agreed? Okay, that's straightforward. All right. The contrapositive then is if it's not February, then it can't be January right now either. It can't be, the previous month can't be January. Okay, so let's look at how they write this down here. See, the one thing I do like about these examples, very few times do I follow the examples. In this case, I do because I like the way they write it out in words for you to make it make sense. So I identify the hypotheses and the conclusion and use the truth table. This month is January, next month is February. So, according to the truth table, that statement is true. I form the inverse by negating the hypothesis and the conclusion. So this month is not January, therefore the next month is not February. Again, false, false makes a true statement. Agreed? Okay. I form the contrapositive by switching the negated hypothesis and conclusion. If the next month is not February, then this month is not January. Agreed? So the false, false, again, makes a true statement. So according to the truth table, the contrapositive is also true. So, not February, then means the month is not January. So if next month is not February, then this month is not January. Full statement is true? Yes? Full statement is true. Okay? So my whole point to what we have done today is to go through this process and hammer that out first. All right? It is far easier to look at these questions when I read them out in words, the entire statement. If I shorten them, which I have done, the Saturday movies, not Saturday, not movies, that makes it more complicated, just like the January and the February one. If you just switch the statement, the actual wording of the statement, as opposed to shortcut it, I think you'll get a better understanding of it. Okay? Go to page 77. Question 1. If I am reading, then I am studying. What's the hypothesis?
If you're reading,
If I'm reading, what's the conclusion?
you're studying.
I'm studying. Is the conditional statement true? If it is false, provide a counterexample. Is
You don't have to be studying in order to read.
Okay, so is the conditional statement true? Is the conditional statement true? That's my question.
It is.
At all times?
No, because if you're reading, you're always learning. You're always picking up on stuff. So technically, you are like studying something. You're reading, like whether you're reading like this up is advice. If you're picking up on stuff and you're studying it.
What if you
No,
pick
not
up a novel?
necessarily. Yeah, it could be a
When you're
problem.
picking up on people, you're learning about the novel. Like, you know what I mean? Like, no matter what you're reading, you're always learning about something. Are you always reading
I
it?
think.
Not necessarily.
I think
Mine
mine
is
is
to
to
read, because you know what?
You are. The answer, of course, is not true. You can read for enjoyment, I guess, is what they're saying. Do you necessarily, like, do you pick something up? Absolutely. Does it tell you a story? Yes. Do you use your imagination? Yes. Are you visualizing? Yes. The whole point of the question, don't make it complicated for yourselves. If I am reading, I could be doing it for fun. Or I could be doing it because I'm studying. I'm reading a textbook. So that's where they're at with it. Write the converse. If I am studying, then I'm reading. True or false? If I'm studying, then I'm reading.
True.
Why?
Because you study something else.
Okay? You're absolutely right. I might be doing math questions. That's studying, right?
You're just still reading.
You're still reading the problem.
Watch a video.
No, I'm not reading a question if it's not a word problem. Am I?
Reading a number, you're reading. Then what is it called when you're looking at numbers?
Okay.
That's not-
Gimmick.
For some of us, that's true. Okay? All right. I guess what we're taking from this conversation right now is don't overthink it.
It's literally
It
my
should not
back
be.
reason why I overthink.
That is not causing. You do not overthink. Or anything.
You know what I mean? I just gotta say.
All right. You had questions from yesterday.
I
One.
just have one. I
Okay.
couldn't get it. It's on page 71, multiple choice.
Number 9. Jai asked 111 people what type of television show they like. 61 like police drama, 78 like comedies, 14 like neither type of show. Okay, from your steps, what's the first thing that we should be doing?
Like, both.
What's the first thing you do? Didn't like any, so that was 14. Okay, and what do I take that number off of? 111. Okay, so I go 111 minus 14, which is equal to 97. All right? But then I had 61 and 78. How much does that make? Well, you off your calculator.
139.
So 139 minus 97.
32.
What is it?
32.
Okay. What does that number identify?
People, how many people?
People like both. So we draw ours out. 42 goes in the middle,
Okay.
correct?
I know what I did wrong now. And then you just subtract 42 on the sides. You subtract 42.
Yes.
Okay, yeah. That's right.
Okay? Everybody follow that example? All right. So the first thing you gotta do is take away the ones that didn't like anything, okay? And then I add the other two together and take away whatever I had left of the 97 because that's how many like both of them. All right? Okay, any other questions from yesterday?
I think that's backwards. How you did it, but I got the right answer.
Okay, now, you're gonna
And I
find it.
got the right answer for every single one, and I do it completely backwards.
That's fine. Yeah. If you have your own way of doing this logic, that's the one thing about it, is it's not necessarily set up for one method, one way to do things. You can think things through logically in a different way than somebody else, so be it.
So if you guys have enough for logic.
Amen, brother. No.